Oh, hey. Hi there. I see you've come to study. Well, that's perfect, because I came to teach. All right, let's do a little bit of review. Let's start right away here with talking about matter. Matter can be split up into mixtures and pure substances. Now, we can split those two up even further, right? Pure substances can be split up into elements and into compounds. Mixtures can be split up into solutions and mechanical mixtures. Let's talk a little bit more about each of those. So pure is something that's made up of only one type of particle. It could be one type of element, it could be one type of compound, but really we have one particle. A mixture, we're going to have a combination. That means we're going to have more than one thing, particle, all mixed together. Like these Skittles or these M&Ms. All different colors, all mixed together. Now let's talk about the specific types of pure compounds and mixtures that we have. So, for example, elements. Elements is a type of pure substance. Elements are on the periodic table. And elements are usually only made up of one atom. One atom. Gold is an element. Gold is pure. Gold is made up of one atom. Copper is one type of element. It's made up of one type of atom. It is a pure substance. Aluminium or aluminum, one type of atom, one type of pure substance. All these things are pure. They're made up of one type of atom. Compounds, on the other hand, are also pure, but they're made up of more than one type of element. For a compound, we have 2 or 3 elements stuck together, and they tend to repeat again and 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 again. So for example, water. Water is an example. It's hydrogen, 2 hydrogens with an oxygen. Ammonia is another compound example. We have 3 hydrogens and a nitrogen. In an ammonia compound, it would be these 4 things, or these 2 things, put together again and again. A compound is pure because we have 2 more different elements stuck together and they always repeat. So elements and compounds, those are our 2 kinds of pure mixture. But now let's get into it. Let's get into the mixtures themselves. We have 2 types of mixtures. We've got solutions and we've got mechanical mixtures. Let's start with solutions. Solutions are also known as homogeneous mixtures. They're an even mixture, which means both substances are so completely mixed you cannot see all the different things that are in this mixture. Think about soda. Soda has got usually caramel, it's got sugar, it's got CO2, it's got water, and it's got other natural flavors. But all those things are mixed together. And when you look at it, all you see is that soda, right? You don't see each of the individual things, you only see soda. My picture here of this red tea, we're mixing in some sugar. You cannot see all the different parts of this mixture, right? That means it's a solution. If you can't see all the different parts, you got yourself a solution. You got yourself a homogeneous mixture. A mechanical mixture or a heterogeneous mixture is an uneven mixture, which means you can see all the different types of substances mixed in. You can see, for example, in this pizza, you can see the pepperoni, you can see the onions, you can see the olives, the cheese, the tomato sauce, the tomatoes, the crust, the bread. You can see everything. Mechanical mixture does not discriminate. You can see all the different parts. And that is all we need to know about the different types of pure versus mixture things. So now let's jump into the atom. First things we need to remember about the atom. Atoms are small. They're very, very small. You need to remember this. Ladybug is tiny. The antenna of a ladybug is even tinier. Atoms are smaller than that. This small piece of pollen that comes from a plant stuck to the hairs of the antenna of the ladybug. Tiny. Atoms are smaller than that. We have to keep in mind atoms smaller than 0.2 nanometers across. They're incredibly small. But even though they're small, they're still made up of different things. They're made up of 3 particles. We call them subatomic particles. Protons, neutrons, and electrons. These are the three subatomic particles that make up an atom. Now, we have to remember two things about each of these subatomic particles. We need to remember their relative mass and their relative charge. It would also be helpful if we remember their location. So, now let's think about where these are. We have, let's talk about each of these. I'm sorry. Lost my train of thought there. Let's talk about these subatomic particles. Let's start with the electron. Electrons are negative. They're -1, and they weigh very, very little. Usually we just round to 0. We say they don't weigh anything because they're so tiny. Electrons are normally located as a cloud or in a shell around the nucleus. If I bring up a picture here, we can see our electrons on the outside. Electrons, again, exist in a cloud or in a shell around the nucleus. And their charge is 1. Next up, we've got protons. Protons are a positive 1. They are +1. And their mass is 1. They weigh 1. So they're +1 and they weigh 1. Protons are found in the middle of the atom. They are positive and found in the middle. The middle of an atom is called the nucleus. Now, protons aren't by themselves, right? In the middle of the atom, we also have the nucleus, an N. Nucleus N. The nucleus does not have a charge. There's no charge here, no plus, no minus, but they do weigh 1. They weigh 1. Now let's look at that a little bit more closely. Here we have another picture of the atom. Here in yellow, in this little yellow circle, this is our nucleus. Remember, the nucleus is the center of an atom. We have protons and we have neutrons in the center. Electrons exist as shells or clouds around the outside of the nucleus. And those are all the different parts of the atom you need to know. Now, the other thing we need to know for the quiz are reading a periodic table. Everything you need to know about reading the periodic table really is on this slide. We need to know what this number on top means. This is the atomic number. The atomic number is equal to the number of protons and the number of electrons. That is our atomic number up here. Our number down here is the atomic mass. The atomic mass is how heavy your atom is. How heavy? How much does it weigh? That's what this number on the bottom tells you. Now, in order to find that, you need to add together protons and neutrons. That's how we find the atomic mass, or the mass number. We add together protons plus the neutrons, and that gives us the atomic number. So, for example, the atomic number for hydrogen is 1, because the protons equal 1. Neutrons are 0, so the mass number for hydrogen is 1. If we wanted to find the mass number for lithium, we need to add together protons and neutrons. We add those two together, we get 7. Mass numbers are easy. We just need to add together protons and neutrons. All right, now the final vocab word is isotope. But I cover isotope in my other video. Go watch my other video. You'll learn all about isotopes. Okay, that's it, you guys. I hope this was a helpful video. I'll see you all tomorrow in class. Good luck studying, and if you have any questions, feel free to email me. Bye.